Hey guys, Mr. Milton here. Today we're going to look at trig ratios, the first unit in our trigonometry chapter for geometry. Okay, at the end of this video you should be able to identify trig ratios in right triangles, and you should be able to find side lengths of right triangles using trig. Okay, alright, in any right triangle there is one right angle and two acute angles. Okay, and we'll call this, you see in this triangle, angle C is the right angle, and then angles A and B are the acute angles. Acute just means less than 90, right? Okay. And in the trig we will be looking at today, you must have a right triangle, but the trig function ratios are found with respect to the two acute angles. Okay, so when we're looking at those trig ratios, we'll look from angle B and angle A, and we'll talk about that. The three trig ratios that we'll look at today are sine, and we'll write that as S-I-N, cosine, C-O-S, tangent, T-A-N. Okay, so these are just abbreviations. Okay, each of these refers to ratios of certain sides of the right triangle with respect to a certain angle. Okay. The sine of angle A, written as sine A, is the ratio of the length of opposite sides of the opposite side of angle A over the hypotenuse. And so we're looking at from here, I like to draw an eyeball here because we're looking from A. Okay, the opposite side is the side that doesn't make up the angle, so you see that side B and side C make up the angle. The opposite side, A, and the hypotenuse is always the side that the right angle points to, C. Okay. Think about anything more. Okay. Sine of an angle is always the length of the opposite side of that angle over the hypotenuse. Cosine is always the length of the adjacent side and over the hypotenuse. And tangent is always the length of the opposite side over the adjacent side. Okay. Alright, so looking at this triangle at the top here, we're going to write the trig ratios given to us. So we have sine A. So sine is opposite and hypotenuse, and again, I've already written this up here, but sine A opposite A over the hypotenuse C. Cosine A. Cosine we said was the adjacent, so the adjacent is the side that's next to it, the side that does make it up, but not the hypotenuse. Hypotenuse is always going to be the hypotenuse. So adjacent is going to be B over the hypotenuse C. And then tangent A. Tangent was opposite A over adjacent B. Okay. Alright, sine B. So now we're looking from this angle. Sine is opposite from B, side B, over hypotenuse C. Cosine is adjacent B, which is A, over the hypotenuse C. And then tangent will be opposite over adjacent, so B over A. Okay, and we'll look at how we can remember those relationships a little bit easier as we flip to the back. Okay, notice that the sine of a particular angle is equal to the cosine of the other angle. So you see sine A, A over C, is always the same as cosine B, the other angle. Okay, A over C. Okay. The tangent of a particular angle is the opposite, or the reciprocal. Better, well, I should say the reciprocal of the tangent of the other angle. So for tangent A we had A over B, for tangent B we have B over A. Okay, it's just this reciprocal. Alright? Okay, so now you might have thought like, wow, I'm not going to be able to set up those ratios that fast. But here's a common acronym that's used to remember those trig ratios. It goes SOHCAHTOA. SOHCAHTOA. Okay, and essentially this helps us to remember our ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Got a couple different ways to remember that I can help you guys out with if you have questions. Okay. So what we're going to do is we're going to write each of the trig figures, each of the trig ratios below. And when you write the trig ratios, you must always simplify your ratios and put them in simplified radical form. And all that means is that you cannot have radicals in the denominator. Okay, so here we're given a right triangle. Okay, and we're asked to find the length of AC. And we can find the length of AC because it's a right triangle by using Pythagorean's theorem. Pythagorean's theorem, a squared plus b squared equals c squared. Alright, we know that a is 10, b squared is 15. Oh, nope, sorry, that's not right. B squared will be b squared. The only side that matters is c, the hypotenuse. It matters that we call that c. Okay, so as we do this, 100 plus b squared equals 225. B squared will equal 125. B, then, we take the square root of this. Square root of 125, just as a review, remember guys, you can do the number tree, break down your factors, take out your pairs, and we find that that missing side length, side of AC, should be 5 radical 5. Alright? And we'll be better to write this as a radical rather than a decimal, so don't round this to decimal unless the directions tell you to give your answer that way. Okay, so the length of AC is 5 radical 5. And now we're going to find the cosine, or set up the cosine of these angles. So we have cosine B. We're just writing these ratios. We start from B. Our cosine, remember, is adjacent over hypotenuse. So our adjacent 10, our hypotenuse 15. So you'd want to naturally say 10 over 15, but as you write these ratios, remember you need to simplify. So it's 2 over 3. So what we should have. Okay. Our tangent of B is opposite, 5 radical 5, over adjacent, 10. This as well simplifies. We have radical 5 over 2. And then for sine B, that is opposite over hypotenuse, so 5 radical 5 over 15, which simplifies to radical 5 over 3. Okay, so again, once you get that SOHCAHTOA down, and those setting up the ratios are pretty simple. Alright, so cosine C, again, C is our acute angle, so we can look from there. So cosine of C, cosine is adjacent over hypotenuse. That's 5 radical 5 over 15. Again, you should see that sine of B is the same as cosine of C, radical 5 over 3. Okay, tangent C. Remember that we said that it was going to be the inverse, or sorry, the reciprocal of tangent B, but we'll look at it opposite over adjacent. So we have 10 over 5 radical 5. Remember, as we write this in simplified radical form, that we cannot have a radical in the denominator. So when we simplify it, we would get 2 over radical 5, but we still have a radical in the denominator. Remember, to get rid of that radical, we have to rationalize the denominator, and we do that just by multiplying by the top and the bottom by that radical. Okay? Remember, just kind of a quick explanation. This is 1. Radical 5 divided by radical 5 is 1. Okay, and so anytime you multiply by 1, you don't change the number, so it works. So we have 2 radical 5 over 5. And that's how we write this function, or this ratio. And then sine C, will be opposite of C, 10 over the hypotenuse, which is 15. And simplify that, that's 2/3. Okay. Notice we never have trig ratios with the right angle. So in this case, angle A, we won't look at sine of A or cosine of A. And the reason is that the opposite side of A is also the hypotenuse. So the opposite side of A is also the hypotenuse, so it really eliminates our ratios. We can't use those. Okay, so these ratios are used to find missing sides and angles. Today we're going to talk about how we can use these ratios to find missing sides of right triangles. Okay, and so let's set up these ratios. And what we've had so far, we've known all the sides. And from here, we're going to now find the sides when we don't know. So we're given in this right triangle, we're given that it's a right triangle, and then we're given that this angle is 53. So what we're going to do is, from this angle, we want to find this side, and we know this side. I always label my sides. So from this angle, this is the opposite side. 15 is the hypotenuse. And so now I have to find the ratio that has these letters in it, O and H. Okay, and the ratio that has the letter in it is sine. So my equation is going to say sine of 53 equals the opposite, which is x in this case, over the hypotenuse, which is 15. Okay. Now in your calculator, just want to show you something really quick. You'll notice that sine of 53 is a value. Okay, it's a decimal. We will do our work on paper before we ever hit anything into the calculator. Okay, that way we don't have to round and get off numbers. So I want to solve for x. I'm going to get x by itself. I'll do that by multiplying both sides by 15. And so I have 15 times sine of 53 equals x. Okay, again, remember, sine of 53 is one thing. It's together. So in my calculator, I'll say 15 times sine 53. And that's 11.979. Tells me to round to the nearest tenth. So that means I'm going to round to 12.0. Okay. In this next problem, I'm trying to find B. I'm given this angle 25. B from there is my opposite side. 8 is my adjacent side. And so the function with the ratio with opposite and adjacent is tangent. I'm going to say, okay, tangent of 25 equals the opposite, B, over the adjacent, 8. Okay, now I'm going to solve for B. Multiply both sides by 8, get 8 tangent 25 equals B, and then I'll do that in my calculator. 8 times tangent 25 is 3.73. If you're getting different numbers than I am, and since it says round to the nearest tenth, 3.7. If you're getting different numbers than I am, make sure your calculator is set to degrees and not radians. Okay. Number 3, a couple things that you should look out for. First of all, you should make sure that it is a right angle. In number 3, they do not tell us that this is a right angle, and so without knowing that this is a right triangle, we wouldn't be able to use these functions. Okay, so just for the extra practice, I'll say, hey, we know this is a right triangle. Let's find H. Okay, so again, remember, if this isn't here, you cannot use these trig functions. But I want the extra practice, so I'm going to put it here. Alright, so here, we want to find H. We're given this angle's 53. So from here, I want to find my opposite side. Okay, and I'm given either an adjacent side or a hypotenuse. I can really choose what I want to use. Okay, and that's only if I have this. So just for this case, let's use the hypotenuse. Sure, I like sine. Or have I not done cosine? Oh yeah, I like sine. So I'll do sine of 53 equals the opposite h over the hypotenuse, 146. Okay, and I'll do 146 times sine 43, or 53. 146 times sine 53. And that gives me 116.6. Okay. Now, finally for 4, we have two unknowns. We can solve them both in the same problem. Okay, even though these problems only have one unknown, we could have solved this side if we were asked to, if we decided to. So in this problem, we're given this angle 30, and we're given that its opposite side is 7. Okay, so we need to solve for A, which is its adjacent side. And so opposite and adjacent, that's tangent. Tangent of the angle I'm given, 30, equals the opposite 7 over the adjacent A. Okay? Alright, now this always becomes tough for people because we have A in the denominator. We can solve this algebraically. We'll multiply both sides by A. Okay, and we get A times tangent 30 equals 7. And then what we'll want to do is we want to divide both sides by tangent 30. Now again, remember that tangent 30 is a number together. Tangent isn't something by itself, and 30 doesn't mean 30 in the way that you're used to it here. So our equation that we would type into our calculator, 7 divided by tangent 30. That will tell us what x is. So 7 divided by, and I always just like to put parentheses around here. It makes me feel like I know I'm doing it right. And so I get A is 12.1, okay, to the nearest 10. Alright, and now we'll do the same thing. I'll help you set up C. Again, 7 is our opposite, C is our hypotenuse. Opposite and the hypotenuse tell us to use sine. So we're going to use sine of 30 equals the opposite 7 over the hypotenuse C. Okay, now you bring this to me tomorrow. See, done. Alright, so hopefully you are able to set up the trig ratios. Also, make sure you're practicing with those ratios so that you, when I say you have the opposite and the adjacent side, you know that that means you have to use tangent. Okay, the more acquainted you are with SOHCAHTOA, the easier it will be for you to set up these problems and solve. Okay, see ya.